Hello, my name is Jimmy Garagorri. I'm Technical Support Engineer for the Hortonworks support team in the Americas East. And we are here to show you how to configure Hortonworks SmartSense tool with custom CA signed certificates. In this video, we will be defining briefly the Hortonworks SmartSense tool, the server and agent communication process, and the environment used to complete this demo. Finally, we will be configuring the HST server to use certificate bundles received from a custom CA to sign all the HST agents. Additionally, for this video, we will be switching between the presentation, the Envy UI, and a terminal where we are going to execute all the commands to validate the current configuration and complete the setup for the custom CA certificate for the HST server. The HST agents capture, anonymize, and encrypt cluster diagnostic data, and then send it to a central HST server to consolidate into a single downloadable file called bundle. HST agents are installed on every node in the cluster and are started only for specific data capture tasks. Once the agent has captured the request data from the host is installed on, the process exits. When deploying SmartSense in an enterprise environment, by default, all the communications between the HST server and the HST agents are initiated by the agents, using TCP ports 9440 when the communication is one-way SSL, and 9441 when the communication is two-way SSL. All HST agents register themselves with the HST server using a two-way SSL setup with a self-signed certificate. When invoked to capture data, the HST agent uses the same port to securely transmit the captured data back to the HST server. When HST server starts the first time, you will notice in the log how the HST server is configured as a certificate authority to sign all the HST agent requests. First, you will see the command used to create the private key, which will be used to sign all the HST agents signing requests, and a creation of a bundle identified as keystore.p12. Now, when the HST agents start, they will try to get a root certificate from the HST server and will send a certificate signing request to get signed by the certificate authority in the HST server. This behavior could be monitored in the agent log during the HST agent's start process. Once the HST agent sends the certificate signing request, the HST server will sign the server certificate using the CA certificate and the private key. Each time the HST agent starts, it will be sending a certificate signing request to get a valid certificate from the HST server. In this way, we'll complete the two-way SSL communication between the server and the agent. All the information for the agent certificate will be regenerated automatically every time the service starts and will be cleaned out every time the service stops. Once the certificate is created, the HST server and agent can communicate between them using two-way SSL setup with SSL certificate signed by the HST server. Let's see in detail the information stored in the HST server. From the HST server, we're going to review the content of the main folder for the server. Basically, we can see all the signing requests for all the HST agents and all the certificates signed by the HST CA using the CA cert and the CA key. As you can see, we have a different file here. It's a pass.txt. This file holds the password information to be able to read the content for the ca.key and for the bundle keystore.p12. To review the information for the private key, we can execute the OpenSSL command, and we need to provide this password to be able to read the information in the private key. As you can see, the private key is an RSA private key. Additionally, we can see the information in the certificate that's going to be used by HST Server to sign all the requests for the agents. To do that, we can execute an OpenSSL command, and you can see this information is for a default installation of a SmartSense, because it's using default city, default company, and you can see the whole information for the certificate. You can see the extension for this certificate, the constraints for this certificate. These constraints, CA true, said that this certificate is going to be used to sign other certificates. Now we already understand the SmartSense architecture for the SSL communication. It's time to show you the environment that we'll be using to complete the configuration for use CA sign certificates for the HST server. In this section of the video, we'll be using a custom environment to replicate some configurations and try to use a custom CA certificate to replace the normal behavior for HST server. For this video, we will be using a 4-node cluster managed by Ambari with a SmartSense installation composed by an HST server and 3 HST agents. One of those agents in the same server as the HST server. With this cluster, we will show you how to replace the self-signed certificate deployed in a default SmartSense installation. The HST server is located in the node 2. This node has an HST server and an HST agent. Additionally, we will be using variables to hold the information for HST server hostname, the one-way and two-way SSL ports, and the path for Java, which is used by HST server. You can see most of the commands are going to be used during this video, so basically we are going to execute those commands and see the content that's going to hold in those variables. This variable will hold the information for the server. This variable will hold the information for the current Java programs is in place for the HST server. This variable will hold the information for one-way SSL ports, and this command will be holding the information for the SSL port for two-way SSL communications. We can see the information for each one. And the information for the Java. And the information for the ports P1 and P2. Before to start configuring our HST server to use custom CA certificate, I will show you the current SSL configurations, the current SSL certificate in place by the default installation of SmartSense. To do that, we are going to use OpenSSL client connect with the information, the previous variables. We can validate the connection for the HST server using the port for one-way SSL authentication, and we can see it's a default certificate, it's a current default installation for SmartSense. We can do the same for the other port. For the port two-way SSL configuration, we can see the default installation too. Now we already validate that the certificate in place is a default installation. So basically, we're going to take a backup of the configurations to a folder just in case you want to get back to the previous configurations. To do that, we are going to execute a tar command. Now we have a backup in the folder SRV. With all this information, now we can proceed to enable the configuration in the next section of this video. For this part of the video, we're going to configure the HST server using a bundle PKCS 12. Most of CA sign certificate comes in bundles. The PKCS 12 is a bundle in binary format for storing the server certificate, any intermediate certificate, and the private key into a single encryptable file. These files are usually found with the extensions .pfx and .p12 and are typically used to import and export certificates with their private keys. Let's see what we have for this setup in the server. We have all the certificates in these folders. In this folder, as you can see, we have the bundle P12 here. Basically, we can use the key tool command to view the information in this bundle. Without a password, we can see the summary, and we can notice that we have only one entry for the server, and it's a entry for the server with a private key entry. If we execute the same command, but in this case we are going to provide the password, we can see more detailed information. In this output, we can see the bundle has two entries, one for the certificate of the server and one for the root certificate. You can see the certificate number 1 is for the server and has a certificate chain of 2 certificates, the certificate itself and the root certificate, and the entity that's signing the certificate. The certificate for the server is a certificate with a extension that allowed server authentication and client authentication. It's a prerequisite to configure the two-way SSL configurations, in this case for the HST environment. Additionally, we can focus on this part of the configuration. The certificate number 2 is the root certificate, and it has an extensions and constraints to be used as a certificate to sign other certificates. So, with all this information in our hands, we already know about the bundle. So we need to extract some information from here. So back to the presentation. Let's see how is the configuration for this. When you receive a bundle from the CA, this bundle could be a PKCS 12. And in the case you are receiving a PKCS 12, you need to extract the private key from here and get the certificate chain from the bundle. If the private key you get from the bundle is an encrypted one, you need to unencrypt that private key to be able to sign all the requests for the HST agents. So basically, you have an environment for HST server which need a configuration for key store, P12 file, and a certificate and a private key to be able to sign all the certificates. Basically, we can see the summary of the command you can execute to be able to get all the requests. So basically, we are going to execute the same in the terminal. in a order to get the private key, we need to execute following command. Open SSL. We need to provide a password. And for the output of the output file, we need to provide a password. I'm using the same. I made a mistake with the password, so let's do it again and see what happens. Provide a password. Double check the following password. Okay, now we have two files. This file, if you see, is a private key encrypted. So we need that private key in and without encryption. So basically we are going to execute an OpenSSL command to get the private key without the cipher, without the encrypted configuration. We can see now we have the private key. It's time to get the certificate chain. To do this, we are going to execute this command. Now we have the CA files required to replace in the configuration. So basically we have the bundle, we have the certificate, and we have the private key. Now we need to stop the services for SmartSense using Ambari. Because we are going to replace some information for the environment. So before to remove and reconfigure everything in the server, we need to stop all the services. Now we have all the components in a stop state. So now we need to clean it out all the information for the previous configurations. So basically we are going to execute this. And remember, we are going to create a pass.txt file with the password for the bundle. Once we have all the steps executed, now we need to copy all the information required to the new destination. So basically we are going to copy the certificate to the right location. In this case we are going to execute this. And finally we are going to copy the bundle and save the bundle with the name keystore.b12. Now with the certificate in place, it's time to see the server log. So basically we are going to use a tailf command to double check all the information during the boot process or start up process for this HST. So we are going to back to the Ambari UI and try to start again the services. Back to the terminal and see what happened. As you can see, it's trying to use the same version of Java and trying to start the service. And you can see they are successfully started, and we can notice the port for one-way SSL communications and the port for two-way SSL configuration. So basically we already have the certificate in place, so we can double check if the certificate is according to the one we need to use in this environment. For this we're going to use our certificate, and you can see in our certificate every configuration is different for the default one. Now we have a certificate chain with the different information here in Santiago, and we have the certificate for the server is using different configuration for the default one. We can do the same for the other port. As you can see, we have the information for the certificate number 1, certificate number 2, and all the information is now different for the default installation. So basically, we have already put in place the certificate for HST Server. Now, if we remember the procedure, all the agents need to send the information for sign a certificate and to be able to establish a two-way SSL configuration. So basically, we are going to start the service are already start. All the agents are start. So information for the agents will be in var lead SmartSense HST agents /keys. As you can see, we have all the information there. Basically, just create it, and we can validate this information executing open SSL x509 using this path and the certificate for this agent. As you can see, it's a custom certificate. Certificate for a root CA. So we can compare this information with the other host in the cluster. We can review the same for different node. So we can execute the same command, but now we can use OpenSSL x509 var lib SmartSense HST agent keys, and the certificate for the server will be this. As you can see, it's a different certificate. This is a node 3. Now we can review the information. It's different to the default city. So basically, we are already configured the environment. As you can see, everything is green. Now HST Server and HST Agent has configured the certificate to be able to communicate using two-way SSL, and all the certificate for the agents are signed by the certificate in the HST Server. After this, we already replace the certificate for the server, and we are ready to move to the next section of this video. Now to the final part of the video, we are going to configure HST Server using a bundle, in this case PKCS 7. PKCS 7 is one of the most famous and extensively used standards from the series of public key cryptography standards by RCA Security for the exchange of digital certificates in the public key cryptography. A P7B file only contains certificates and chain certificates, including intermediate certificate authority, but not the private key. So we will need the private key used to request the certificate to the certificate authority to sign our certificate. Basically, you need to have the private key in some place with P7B to be able to complete this setup. Let's see what we have for this environment. Back to the terminal. We have a bundle here. This is not the server, so we need to back to the server where we have the certificates. We have the certificate here. So let's see what we have here. As you can see, we have the private key used to create a signing request to the CA and the bundle provided by the CA. To see the information in this bundle, we can execute this command. As you can see, all the information in this bundle is different from the previous one because here only you will see certificate information, and you will notice that it's not in this file is not anything related to the private entry that we saw in the P12 bundle before. So back to the presentation, we have the same diagram for the previous one. From your custom CA, you need to request with your private key, you need to request to sign your certificate to a CA. Basically, the CA provides you a bundle. This bundle will be a PKCS 7. And when you have a PKCS 7 bundle, you need to convert it to a PIMP format before to proceed with the configuration. And you need to create a PKCS 12 bundle. Remember, the PKCS 7 doesn't include the private key. So when you convert to PIMP and when you create a PKCS 12, you get a certificate chain and you get a bundle. That's a prerequisite to complete the configuration for HST Server. Remember, we have all the information for this server in HST Server. So before to proceed, what we need to do is stop SmartSense and replace the current information. From the previous execution, we have already set in place the certificate for the custom CA. So basically, we are going to restore all the information that we did at the beginning of the video. And after this, we are going to show you how to replace this certificate when you receive a bundle in a different format. So back to the terminal, we need to validate the information currently in place. Remember the OpenSSL command. Basically, we need to validate if Ambari is stopped. Now, SmartSense, we need to stop from Ambari to SmartSense before to do any change. Once the server has all the components in stop state, we can proceed. Go to the terminal and let's do the following. Remember, we already took a backup, so basically we're going to restore the backup, and now we're going to start the services. We need to wait a couple of seconds because trying to sign some certificate to be able to start the agent. Normal behavior. And after this is complete, we can review if in fact we are going to use the default configuration for the certificate before to replace them. Okay, we already have the server start. Now we are going to see the agent starting, complete start. Okay, back to the terminal, and from the terminal we are going to validate what the certificate is. So the certificate in place again is the default one. Now we can proceed. Again, we need to stop the SmartSense before to do anything. According to the diagram, we need to convert the certificate to the PIM format, and we need to create a PKCS 12 bundle. So now everything is stopped, we can proceed. To do this, we're going to use the information in terminal. Remember, we only have this, so we're going to execute this command. And now we already have the certificate. Convert into a format, into a PEM format. Basically, it's a container with a concatenate certificate. And we need this certificate to be able to create the PKCS 12 bundle. Now, to create a bundle or PKCS 12, we are going to use this command. And as you can see, we already have P12 file there too. Now we have the CRT, we have the key file and the P12 file. With this information in place, now we can clean up all the information for the previous configuration. So it's the same that we execute before. The same situation for the pass.txt file. We need to create this file. Now we already have the CRT, the key file, so we need to copy the information in to corresponding destination. So remember, we have the CRT file, so we need to copy this file to this location, and we need to call the file as CRT. We need to copy the file to the location, and we need to call as ca.key. And finally, we need to copy the bundle, and we need to call this bundle as keystore.p12. If we review the information here, we can see we don't have anything apart the files that we are already copy here. So we are ready to repeat the procedure to see the content of the log file before to start from Ambari, the service. And we can see now what's going on in this. Start 9440, 9441. And if we can see, starting the components, trying to start the server, start the server. Now we need to start the agents. While we are waiting for the agents, we can review the current certificate in place using this command. As you can see, we are now using our custom certificate. All the agents are up and running, so we can connect to one of those agents and we can validate. In this case, I don't know, let's go with this node. In this folder, remember, HST agent, we have the information for this node. So we can use OpenSSL command x509 -text -out -in, and we can use this path with this certificate, and we can view all the details. It's a custom certificate in place. So basically we have already configured this. At this point we have already completed the setup. So the information is updated with the custom certificates, and with these steps we already execute the test to change the configuration, the default installation for the SmartSense using bundles, two different bundles, the PKCS 12 and the PKCS 7. So basically we already did all what we require. Thank you for watching this video. Stay tuned for more.